Okay, we're going to talk a little bit about queries. This is the last chapter that's going to be included on your uh, exam number 3, the second take-home exam. What is a query? They're just basically a fundamental analysis technique. It's a way of extracting some data from a larger group, and you do this based on one or two things. By selecting a subset based on attributes or a subset based on location. So what are some examples? Selecting features of interest like wells and high iron concentrations. Looking for things like spatial patterns like where gold mines are versus other mines. Isolating features for more analysis. You pull out a set of data that's what you're interested in studying. You can explore spatial relationships, like looking for water hazards where roads cross certain types of structures. And you can create raster queries, like where you find tree canopies of greater than 40% or elevations over a certain level. In terms of types of queries, in an interactive query, the user visually identifies the desired features in a map or records in a table. What does that mean? It means that on the map you select something, or in the attribute table you select something, and basically it's just a simple expression like counties with populations over this amount, or cities are within a distance of a feature from another class. There's various operators that are used in this process, basic math as well as logical ones and Boolean ones, and then spatial ones like intersect and proximity are also ones. Um, all this is loaded up into a GUI to make it more user friendly. This is said GUI. This selects layers by attributes. You basically put in a layer, you tell it what you want it to do, like make a new selection, and then it'll work out an expression based on the things you select and the stuff that you tell it to do, and then it'll find the data that you're looking for. The clause builder is an easy, intuitive way to enter expressions. Occasionally, it's convenient or necessary to write the expression directly. The problem with that is that most of this stuff is highly sensitive to spelling and case, and so you want to use the GUI as much as possible and only resort to typing when you absolutely have to. Boolean operators are useful when you have multiple conditions that have to be tested for. So instead of just looking for a single thing, you can look for one thing and something else. So if you have two conditions that must be met, Boolean operators like ands and ors will do that. There's others, and Price will go over those in some detail in the tutorials, and you'll get a chance to see what they are. These diagrams just explain like A and B. You see the common space, A or B. It's both A, not B. A and not B is the areas it's an A, and the areas it's B but not the common. A and not B is A minus anything in it, it's in B. You can see how that sort of work out. This is a nice diagram to understand how this works. Circle T is all the students, A is all the geography majors, B are the students from New York, and C are the students from New Jersey. You'll notice that A and B and C, A overlaps with both B and C because geography majors could come from New York or New Jersey, but B doesn't overlap with C because you're either from New York or you're from New Jersey. So you can use this as a means of looking for things like major equals geography and state equals New York, in which case you would find the students that are in part A, geography, and New York State, which I believe was B. So the common space to A and B That is, geography majors from New York at the university. That's how it works. And versus, I'm not going to go through all these, but you get the idea. You can sort of read here what it tells you. If you're looking for state New Jersey and state New York, so that's part A and part B. Actually, it's not A and B, it's C and B, and C and B don't overlap, so there are none. Now, if you selected or instead of and, C or B, then it would be all the space in C and all the space in B. If it was geography majors in C or B, it would be the spaces in A that is part of C or B. Unlike arithmetic operators, Boolean operators have no order of precedence, so it doesn't matter which direction you go. They work. They're not commutative. Order of precedence. Multiple conditions are evaluated from left to right unless parentheses are used to change the order. You'll get different things if you don't pay attention to parentheses. You do what's in the parentheses first and then left to right. So you're starting left to right and then you do what's inside the parentheses. It will give you very different outputs if you don't do it correctly. Partial matches are another common thing to this concept of queries. You can use these little quote marks and it will look for things that contain the text stone. So it won't have to just say stone, it'll be anything that has the word stone in it. Spatial queries are very different. Spatial queries test the spatial relationship between two layers. Okay, so instead of just looking at the attributes, you're looking at the spatial location of features. And so you're looking, for example, counties that contain a volcano, counties that intersect rivers, parcels within floodplains, cities within a certain distance of a park. It's all spatially motivated. There are a ton of spatial operators, intersect 3D within a distance, all these different contains and different boundary types. And basically these things look at stuff like intersect, contains, and proximity. Different types of containment. Contain operators permit the feature to lie on the edge. In other words, it can share the boundary with the thing that you're using to contain it. And then there's completely contained. With completely contains, the operator does not permit a shared boundary. In other words, it cannot touch the boundary. There has to be something of the inside between it and the boundary. That's why in the state here, the ones that are in blue, they are completely contained because the yellow counties surround them. But they are completely contained within that black boundary. Target and source. When you're going through your teaching tutorials, listen to what Price says in terms of understanding this to do the exercises, but don't get wrapped up in the idea of target and source. Select by location has its own GUI as well, and you simply put in the various targets and features and things, and it'll run the tools. Here are 3 basic examples of different types of spatial queries. And here are some more. What are the limitations of spatial queries? They can only select or not select entire features. So in selecting rivers that intersect Texas, you get the entire length of the river, some of which lies outside of the state. Selecting rivers within Texas won't yield anything. Why? Because none of these rivers start and end within Texas. They all either start somewhere else or they end somewhere else. So if you want to actually, do it differently, you might have to look at something like a clip or an intersect tool. Logical consistency in queries. Logical consistency refers to how well a data set reflects real-world relationships. Data with poor logical consistency may cause queries to work inconsistently. And what we're talking about here is, For example, congressional district boundaries are these light green lines that look brown, and the county boundaries, which are brown, and they should all line up, but looks like here they're not. So what does that mean? Because they don't line up, spatial query using things like contain or within may yield unexpected results. Okay, so you have to be cautious of things like that. Accuracy and precision are also issues that plague spatial queries. Generalized points and lines, like the ones here that represent the Minneapolis-St. Paul and the Mississippi River, do not intersect, even though in the real world entities they do, because the cities here are represented as a single dot, but the city is actually a larger area, and that area does cross the boundaries of the river. Knowing that is kind of an important thing if you're the analyst, and it makes you understand that you can't do that type of a spatial query from a point feature. Buffers are also a type of spatial queries. They basically delineate this area or boundary that is a specific distance from a set of features. Ring buffers is one technique where you show these, like, for example, 100-meter drug-free zones around schools, buffers around streams. You can do a lot of different types of these things, as well as dissolving and not dissolving. If you're curious what those are, when you open up a tool working through the tutorials, check out the options and the tool help and see what it tells you. Or you can just wait till this slide and see that when you dissolve, it basically dissolves, whereas in the one above, each segment gets its own buffer, and if two segments, for example, overlap, if the buffers overlap, they're still individual buffers. But if you dissolve them, instead of having all those goofy looking buffers at the top, you have that sort of one big buffer at the bottom. As far as extraction functions, clip and erase are some of the big ones. Clip works like a cookie cutter. It extracts features that lie inside the boundary of another data set. So you have some data set that you're clipping with your cookie cutter. You apply it to some data set, and poof, you get the part of the original data set that would fall within the bounds of the cookie cutter, or the thing you're clipping with. Erase is kind of the opposite. You still have the same idea of the cookie dough and the cookie cutter, but instead of ending up with a cookie, you end up with a dough minus the cookie. What does this do to areas? Long and short, it jacks them all up, okay? I've said this before, and I'm only going to say it 1,000 more times. Shape underscore area and shape underscore length are automatically updated in a feature class in a geodatabase. This refers to when you modify things like this. Those two fields, shape underscore area and shape underscore length, in a very specific set of conditions, feature class and geodatabase, are updated. Everything else is not. Assume anything that has been edited in any way, particularly editing the geometry. Assume all the calculations relative to lengths and areas are incorrect and need to be calculated again. Processing layers with selections. Operations on a layer usually only affect the selected features, so that turns out to be useful. So if you perform summary statistics on the counties, only the selected ones, the ones that you've found that have volcanoes, would be included in that statistic. This is called honoring the selected set. Most, but not all, geoprocessing tools do that. Clip, for example, uses the dataset boundary polygon and does not honor selected features. So Clip is one of the rare tools that don't, but in all other cases, if you have some of the data selected, that's the only data that the geoprocessing you do will be applied to. Interactive selection, there's all these different shape things that you can do. Basically, it means simply selecting it on the map with your mouse, and then that selects everything in the attribute table that goes along with it. You can also go in and make layers selectable or not, so that when you're trying to select things, you don't select too much stuff from other data sets, just the one you're interested in modifying or extracting or doing something with. When you go to create a selection, you have different options. One is to create a new selection. You can also add to a current selection, or you can remove from a current selection, and as well as the others. There's lots of options. So sometimes what appears to be a very unclear process to how to do something is actually quite easy if you can just remember that you can change this selection type and modify what is or is not selected, and what will or will not be selected or added to or taken from that. I hate these colored heart things that they do to try to explain all this, and so I'm not going to go through it. You can work through it in the tutorial. I think this is just confusing and makes it worse. Talk about the two-step. So the selection methods can be used to apply a Boolean operator to two separate queries. This is helpful if you're trying to create a selection based on both attributes and spatial queries. So you could do, for example, maybe an attribute query to select a subset, and then do a spatial query from those selected features. They call it the two-step because you're basically not trying to combine all your analysis into one single process step. You're breaking it up into, I'm going to do this, and then I'm going to do that to it. Using the different selection types can be quite useful. It allows you to come up with some unique combinations of things that will allow you to find out more information by pulling data uniquely from your data sets. Managing your query results. It's often an advantage to preserve a set of selected features for future use, and there are several ways. Make a feature layer tool to create a new layer based on an attribute query is one. Make a new layer from already selected features using a menu item is two. Create a definition query for a layer using the layer properties is three. And export the selected features as a new data set is four. The top three are basically window dressings on an existing data set that don't really change much of anything, and they can cause problems in the geoprocessing. If you need an actual subset, skip down to the last one and export the selected features as a new data set. Make feature layer tool creates a new layer from an attribute query like subregions. Again, the only issue that I have with making layers is that sometimes it can create problems. You'll think you only have that data, but you'll actually have all the data, and that can be a bit of a pain.